Hello and welcome back. In this lecture, I want to discuss some of the specific features related to the C programming language. So we know all the advantages of C. I talked about that kind of ad nauseum. We know that C produces compact and efficient programs. That is a language feature, though. That's important. It's one of the most important programming languages and will continue to be so. We know all this. So I just, again, want to reiterate it. But the main features of the C language are that they're efficient, portable, powerful and flexible, and programmer-oriented. And we're going to cover these in more detail, what this means. But these are important characteristics of C. We need to understand them, again, in order to understand how to write the code in this language. So what does efficiency and portability mean? Well, C is an efficient language. It takes advantage of all the capabilities of current computers. It's very compact programs written in C. They're very fast and compact. I talked earlier about how the mapping of C and C statements to instructions in some language is very efficient. This is one of the reasons it's so fast. One of the complaints about Java in the past used to be, hey, Java's really slow. Well, you don't have this problem with C. When you write a program in C, it runs fast, it's very compact. So that's a language feature. That's an efficiency. Programmers can fine-tune their programs to make them even more efficient because it is such low level. They can use more efficient use of memory. You can't do things like this in Java. Java has its own garbage collector and you can't manipulate the memory to be more efficient. So C is an efficient language. And it's a portable language. So I touched on this briefly in a previous lecture, but this is important because what this means is if you write a C program on one operating system, you can run it on another operating system without modifying it. One of the issues when writing code in today's world is sometimes it's not going to work unless you write it in multiple languages or modify it extensively. So for example, if you write an Android application for an Android phone, it's not going to work on an iOS phone. Right? You don't have those types of issues with C. You write C and it will work on all sorts of different hardware, all sorts of different operating systems. In fact, C is the leader in portability, this capability, and the compilers are easily available. You can get a compiler on Windows, Linux, no problem. Linux, Unix systems typically come with a C compiler, so you don't even have to download it when you're on Linux, Unix. Same with the Macintosh. So you can start writing C programs immediately. No external downloads. They're also available, obviously, for Windows, but typically for Windows, you will have to download a compiler. And we're going to be doing that when we download our required software. So there's a good chance that you get a C compiler for any device that you're using. You could probably get a C compiler also for an Android device or an iOS device. Really low-level micro or mini computers as well, like processors in automobiles. It's also very flexible, which is important, and it's also very powerful. So the Unix Linux kernels are written in C. What is a kernel? Well, we know Unix and Linux is an operating system. We know an operating system will help you more efficiently, a user more efficiently use a computer, and it controls a lot of the aspects of interacting with hardware and so forth. The kernel is the brain of the operating system. So just like a CPU is the brain of a computer, a kernel is where really all the brain and knowledge of the operating system goes. So it typically contains interfaces of the hardware and the kernel. It manages memory. It does all sorts of different things. And that is all written in C. So that can tell you the powerful aspect of the language. If the kernel of an operating system is written in that language is powerful. So many compilers and interpreters for other languages are built on C or have been written in C. So if that doesn't tell you the powerful nature of the language, I don't know what will. But Fortran, Perl, Python, any compilers that are written in those type of languages are written in C. So C programs have been used for solving physics and engineering problems and even for animating special effects for movies. Widely used for many different things. Flexibility is also important, especially when you're a developer and you're writing this code. You want to be able to do things in different ways. You want to be able to solve a problem in many ways. More flexibility, typically, the better. However, there is a trade-off between flexibility and performance. So you want to make, so sometimes it's catchy when you're designing a language. But C was designed to be flexible and is very flexible. So you can do just about everything you want in a C program. You can write all different application types, and you can also manage memory and do different things that many other languages restrict you on. There is a trade-off because sometimes the flexibility causes more bugs or causes developers not to fully understand certain concepts because they may be more complex. But ultimately, flexibility is a good thing, especially if you're a developer that understands the language very well. It's also the basis for more advanced languages such as C++, mentioned that earlier. It's used for developing mobile phone apps in the form of Objective-C. Objective-C is a proprietary language by Apple. Basically, it's C with objects, just like C++, but they decided to write their own language. But it is used in iOS, less and less so because Swift is being more popular. But it's also easy to learn because of its compactness. It's an ideal first language to learn if you want to be a programmer. And I think I've given the rationale for that pretty good. You're going to acquire sufficient knowledge for practical application development very quickly and very easily. So that's why it's a good first one to learn. And that's what you're going to notice in this class is, wow, now that I learned C, wow, it's much easier to learn Java. It's much easier to learn PHP. It's a lot easier to learn these other languages because it has everything that those languages have, and it's very easy to learn. It's programmer-oriented. That's a language feature. It fulfills the needs of the programmers. I told you how Dennis Ritchie, when he created the language, wanted to make it more developer-focused. And he did that. He accomplished that goal. It gives you direct access to hardware. It enables you to direct access to memory and manage your own memory. So the flexibility comes into play when it is programmer-oriented. In Java, you can't do a lot of these things like manage your own memory. C also has many other capabilities that allow flexibility. And I think that flexibility allows be more programmer oriented because programmers like that. They like that flexibility. They don't want to be told what to do. It contains a large selection of operators, which allow you to express yourself succinctly. Now, this means we don't know what an operator is yet, but an operator can be things like adding and subtracting mathematical operators or assignment operators, assigning data to memory. And the more operators you have, allow you to express yourself more in your code. And so a language feature with being more program-oriented is this list of operators, which we're talking about in a lot more detail. It's less strict than most languages, limiting what you can do. Kind of talked about this already. I mentioned the trade-off with this, flexibility versus strictness. It's an advantage in that you can do things in many different ways. However, it could be a danger because it's more prone to error. Programmers, especially with something like pointers. So the fact that you can manage your own memory in C is very flexible, but it's also very complicated sometimes. And as a result, many programmers introduce bugs into programs. Now, Java doesn't allow you to manage your memory, but it's also less flexible, but it also reduces your bugs in your program. So there's a trade-off. You want to basically have flexibility by also allowing things to be less complex. C gives you more freedom, but also puts more responsibility on the developer. And that's why it's program-oriented. C implementations have a large library of useful C functions, so you don't have to write everything in C if you want to do something. Programming languages would typically contain other program functionality that comes with the language. So, for example, if you want to read input from the user, you don't want to write low-level C code to do that. There will be codes in C that already does it for you, and you just reuse that code. And that's usually encapsulated in something called a library. And so C has all sorts of library functions to read data from the keyboard, to write data to files, to create all sorts of nice things with different processes and thread. I mean, all sorts of nice things. So the fact that that a lot of implementation comes with the language and you don't have to actually implement it yourself, you just have to learn how to use the libraries, is very advantageous and very programmer oriented. Some other features of C are it provides low-level features that are generally provided by the lower-level languages. We talked about this. But again, the best example of this is memory management, direct access to memory. Programs can be manipulated using bits. Wow, if that's not low level, I don't know what is. It is the ability to manage memory representation at a bit level. Bits and bytes are how we actually store data on computers. Provides a wide variety of bit manipulation operators. Again, something in the language that we'll talk about in more detail. Pointers play a big role in C. This is a concept that you may have heard of before, you may not have heard of, but it's related to memory management. We're going to have many lectures on pointers. But it is a very, very important feature of C that you should be familiar with at the very high level. C, managed memory. C, pointers. Often when you think of the C programming language, first thing you think of is pointers. And all this is direct access to memory. Disadvantages of C. We talked about that flexibility trade-off, flexibility versus freedom. It also requires added responsibility. Some view this as a disadvantage. Some view that pointers are abused. And as a result, many people write bad C programs. Well, yeah, if you give somebody a tool to do something and they do it incorrectly, who's at fault? It's kind of, again, do you want to restrict that tool because it's abused, or do you want to allow that tool to allow flexibility? So you can often be more flexible, but it's at the risk of making more errors. And a lot of times these errors are very difficult to find and trace, especially if they're memory stuff. So that can be a problem. Other things, because of its wealth of operators and its conciseness, it makes the language difficult to read and follow sometimes. For the most part, C is very easily readable. But if you use a lot of these different operators, that can make it more complex. So there's an opportunity to write obscure code, but any language can be badly written. So you can use the English language when you speak and you can have bad grammar. It's no different when you use a programming language. But some say with C it's a disadvantage because of all these operators. It could be if you use it incorrectly, it can be harder to follow the code. So just to summarize, this is a nice illustration again I found on the web that I'd like to provide you with. The core features of the C language: fast and efficient, portable, a lot of nice libraries where you can reuse code and you don't have to do things on your own. Modularity, talked about earlier, but this is the idea of organizing your code around functions. Easy to extend, and then all these powerful operators that allow you to do things. So a lot of nice features, and most of the features that we just talked about are in many modern languages because they're built off of C.